Okay, in this example, we're gonna see how to analyze a flip-flop, and in this particular example, we have a JK flip-flop. So this is a truth table. Hopefully, you will memorize the table after a couple of examples. So let's assume that this is the clock. This is the clock, and this is the J and K input. So we have some waveforms here for J and K, and let's assume that the flip-flop originally starts at the level 0. Okay, so Q is equal to 0 at the beginning of this process. It is very important to understand, and that's why I included these green dash lines, because the flip-flop, okay, in the way that it works, is a circuit that we call synchronous. Synchronous means that it's gonna check the inputs only when the clock occurs. And when I say the clock, I mean when we have this transition from 0 to 1, okay, and we have another one here from 0 to 1, and you see in all these positive transitions from 0 to 1 is where I mark these green dash lines. And this is important because this is the only time when the flip-flop is gonna go and review what are the inputs in J and in K. It doesn't matter what happened with J and K, okay, during the rest of the clock signal. Okay, it doesn't matter. Okay, J and K could be changing. Okay, going up and down, and the flip-flop is not gonna care. The only time where the flip-flop cares, okay, of what is in J and is in K is when these transitions happen. Okay, that's why we call this synchronous circuit, because it only responds to the time, okay, when it's in synchrony with the clock. So let's assume that we start with Q equal to 0. So in this first transition, when we get to the first transition of the clock, what is the value of J? We see there is a 0, and K there is a 0. So according to the table, 0, 0 corresponds to a Q that stays in the same previous level. So because the level is 0, the next state is going to be 0. So we can go and draw a 0 between this point until the next transition. Why until the next transition? Because in the next transition is where the flip-flop is going to go and read again J and K. So here now J is equal to 1, K is equal to 0. We go here, J1, K0. Now Q has to become a 1. So now Q becomes a 1, and it goes to the next transition. Now in the next transition we have a J equal to 0, and we have a K equal to 0. Okay, that corresponds to a Q that is equal to the previous Q. So we stay in 1. Okay. At this point in the new transition we have a 0 and a 1. And a 0 and a 1 says that Q becomes a 0. So now Q becomes a 0 until the next transition. Here we have a 1 and we have a 1. In 1, 1, this is Q negative. So that means this is the toggle state. So because this is a 0, now it becomes a 1. And here, okay, finally we have a 1 and we have a 0 in this transition. That makes this a 1. So we stay in 1. And this is a way that you are going to be analyzing flip-flops. Okay, please, it's important for you to remember that only in these transitions is when you need to worry about what are the values on the inputs J and K.